Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video, we're going to do an introduction into probability. So when we talk about the probability of something happening, that's something we're going to call an event. We're talking about the likelihood of that event or that occurrence happening. So we'll be looking at what that event is. So it might be, if we were flipping a coin, the event might be flipping a head. Or if we're rolling a die, maybe the event is rolling a 3. Or if we're choosing a card from a deck of cards, the event might be choosing an ace of hearts, and so on. When we're finding or calculating the probability, we need to know what the sample space is. So it's all of the possible outcomes. So for example, if we were talking about flipping a coin, the sample space would consist of a head or a tail. So there's two possibilities. If we're talking about rolling a die, there are 6 possibilities. So the sample space is either rolling a 1 or a 2 or 3 or 4 or 5 or 6, and so on. The way that we calculate the theoretical probability of an event happening is we take the number of ways in which that event can occur, and we divide by the total number of possible outcomes. So for example, if we're talking about flipping a coin and we want to look at the probability of the event being flipping a head, we would say the probability, the head can occur one way, and the total possible number of outcomes would be a head or a tail, so there's 2. So our probability would be 0.5 or 50%. Probabilities are expressed either as decimals or percentages, and the range of values that we can have for probability are from 0 to 1. So if it's impossible for an event to happen, it would have a probability of 0. If it's absolutely certain that the event will happen, that's a probability of 1 or 100%. So it's important to remember that your probability will fall somewhere in between 0 and 1. So we express it as a decimal, and then if we multiply by 100, we can express it as a percent. Let's look at a variety of typical examples. So let's first of all talk about if we were to roll a die, and we're going to assume it's a fair die. We know the sample space. There are 6 possible outcomes. We can either roll a 1, 2, 3, 4, 5, or 6. So if we choose a particular event, such as rolling a particular number, in this case we're going to have our event being roll a 5, we can find the probability of that. So the probability of that event will equal the number of ways we can roll a 5. There's one way. And we divide that by the total number of possible outcomes. There are 6 possible outcomes. So the probability of rolling a 5 would be 1 over 6, which as a decimal is 0.16666. Repeating, I'll round that off to the nearest thousandth, and I can express that as a percent. Let's say our event in our next example is rolling an even number. Again, the probability is found by taking the number of ways we can get that favorable outcome or roll an even number. So that would be if we roll a 2, a 4, or a 6. So there's 3 ways that we could roll an even number. And the total number of possible outcomes is still 6. So the probability of rolling an even number is 0.5 or 50%. Let's say our event is to roll at least a 2. So the probability can be calculated to find out how many outcomes would fit that event. Well, if we roll a 2, 3, 4, 5, or 6, we've got 5 possible ways to roll at least a 2 out of 6 possible outcomes. And if we change that to a decimal, 3 repeating, I'll just round it off, and that would be 83.3%. Another typical example you'll see in probability is when you're tossing coins. In this case, we're going to toss 2 coins. We need to know what the sample space for all the possible outcomes are. And in order to do that, I'm going to introduce a tree diagram. So when we toss our first coin, it could be a head or a tail. Then the second coin, when we toss it, it could be a head or a tail. So that shows us all of the possible outcomes, or a sample space, which would be a head and a head, or first coin head, second coin tail, or first coin tail, second coin head, or first coin tail, second coin tail. So the sample space would have a number of four possible outcomes. So let's take a look at a variety of questions. If our event is tossing at least one tail, the probability of that happening will be equal to the number of ways it can happen, or the number of favorable outcomes. So at least one tail would be this, this, and this. So there's 3 ways to get at least one tail out of a total number of possible outcomes 4. So a 75% chance that we'll get at least one tail when we toss 2 coins. Let's say our event is only having one tail. So again, the probability of that can be obtained by taking the number of ways that we can get just one tail, which would be this possibility and this possibility. So 2 out of possible 4 outcomes. So a 50% chance. Let's say our event is not having any tails. So that probability can be found by looking at the number of ways we can get that outcome. It's only 1 out of how many possible outcomes? 4. So 0.25 or 25%. Let's look at tossing 3 coins. In doing this question, I'm going to show what the sample space is again. So I'm going to use a tree diagram to illustrate that. However, it's not always necessary to show what your sample space is, as long as you know the size of your sample space. So here we're going to toss 3 coins. So the first one will either be a head or a tail. Second coin will either be a head or a tail in both cases. And then the third coin will either be a head or a tail in all of these. So when I look at my sample space, which is a list of all the possible outcomes, we can start here, head, head, head. Then head, head, tail. Then head, tail, head, and so on. So we have 8 possible outcomes, and I've listed what those possibilities are. Another way that we can calculate the number of possible outcomes is each coin has 2 possibilities, and we're tossing 3 of them. So 2 to the power of 3 would be 8 possibilities. All right, let's take a look at the probability of some different events. Our first event is having 3 heads. So our probability of that would be looking at how many ways do we get 3 heads, and there's only one way out of a possible 8, so 0.125 or 12.5%. Let's say our event is having 2 heads, so that probability can be found by finding out how many ways we can get 2 heads. Here's 1, 2, 3. So 3 out of 8 possible outcomes. So 37.5% probability. And let's say our event is having at least 2 heads. So let's take a look at which of these outcomes would fit that. 1, 2, 3, 4. So the probability will be 4 out of a possible 8 outcomes. So 0.5 or 50%. Let's now take a look at cards and look at some probabilities with cards. When we're looking at choosing a card, if you're not familiar with cards, I just want to point out some facts that you need to know. There are 52 cards in a deck, and those 52 cards will consist of 4 suits: diamonds, clubs, spades, and hearts, and each suit has 13 cards. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen, and King. These are called face cards. So our first example is the event choose a king. So the probability of choosing a king is equal to the number of ways you can choose a king. Since there's a king in each suit, there are 4 different kings in the deck. So 4 out of how many cards are there possible to choose? 52. You can leave it as a fraction. You can write it as a decimal or a percent. Next example, if we were wondering what the probability was to choose a red king, it changes. So again, the number of ways we can choose a red king is if we choose a diamond or a heart. Those are both red, so 2 ways out of 52. You can leave it as a fraction or express it as a decimal or as a percent. Last one, if our event is choose a club, the probability of that is the number of ways we can choose a club. Since there are 13 clubs in a deck of cards, there are 13 ways to choose a club out of choosing possible 52 cards. So again, you can leave it as a fraction or a decimal or a percent. So that's an introduction to probability. It gives you an idea of how it's calculated. In the next few videos, I'm going to talk about the difference between probability and odds, and we're going to get into the probability rules. So if you're interested, check it out.